the first 3MT competition at the University of Houston. For those of you that are new to this, the main idea of the competition is for graduate students to communicate their research in 3 minutes with one slide to a non-specialist audience. The 3-minute thesis competition was started at the University of Queensland in Australia in 2008 and has expanded to over 600 universities and 65 countries. We had over 50 students compete in the preliminary rounds on February 1st, and 15 students advanced from the preliminary rounds to today's final round. We have 5 judges joining us today for the final round, and the audience will also have a chance to vote for a People's Choice winner. So have your cell phones ready so you can vote as well. So the judges for today's final round are Lisa German, Dean of the University of Houston Libraries, Monica Thompson, Executive Director of University Career Services, Professor Jennifer Vardaman from the Jack Valenti School of Communication, Professor George Zorodakis from the College of Technology, and Christine Klock, from the Director of Marketing and Communication from the Provost's Office. Thank you to the judges for helping us with today's competition. So thank you all for being here, and let's get started.
All right, we welcome to the stage first, Mr. Fernando Flor.
How strange our universe is. Our universe is so strange that we're capable of probing its genesis 13.8 billion years after its inception. The Big Bang model suggests that everything that we observe around us was generated from the single expansion of a point in space, creating everything, from the stars in the night sky to the subatomic particles that compose you and me. It is postulated that these particles were all generated within the first second of this rapid expansion. Heavy ion collisions are used as a proxy to be able to probe the actual behavior of such an expansion, namely by accelerating protons and or heavy ions very close to the speed of light and having them collide into one another, generating a fireball billions of times hotter than any type of coffee you and I have ever enjoyed. It is my research to elucidate the happenings closely following the rapid expansion of such fireballs. Our current detective methods show definitive evidence that out of these collisions, not only do we generate the particles that compose the protons and the neutrons that any school child is all too familiar with, but also additional heavier entities, simply referred to as strange particles. One can compare this to getting 2 Swiss watches, colliding them into each other, and then having a grandfather clock emerging from the collision. The dynamics which these particles tend to follow show evidence that there was a formation, or there could be a formation, of 2 separate layers as this universal fireball cooled and stabilized. An inner, strange matter surface with a hotter stabilizing temperature than the outer, regular matter surface. Anyone who has enjoyed a delicious lava chocolate cake is all too familiar with such a universal and strange possibility. Richard Feynman once said that the greatest discovery in all of astronomy is that the stars in the night sky are composed of the same particles that we can find here on Earth. It has been hypothesized that such strange matter could be present in the core of very dense objects in the night sky, such as neutron stars. We must not forget that our universe is not only stranger than we imagine, but it is actually stranger than we will ever be capable of imagining. Thank you.
Good afternoon, everyone. So before I start, let me ask you, do you know how much what we look affect our wallet? Maybe you think this question is difficult to answer, then let's turn our attention to our daily life, grocery store. I'm sure some of you may carry a shopping list before go to a store, but according to a study, 16% of the purchase is unplanned purchase. And this 16% of unplanned purchase turns out to be $400 million per year. According to another marketing study, unplanned purchase happened because shoppers' attention got distracted, visual attention specifically. As a marketer, we are interested in bringing new ideas on how to attract shoppers' attention most to improve sales. Therefore, there are tons of paper in marketing that examines how to design the store, how to put the product, etc., to achieve this goal. However, there is no such paper in marketing so far that look at this issue from the perspective of shoppers themselves. Do shoppers display any behavioral tendency during their shopping trip? For example, when they're walking down an aisle, do shoppers more likely look on the right or left? When standing in front of a shelf, which height are shoppers most likely to take a look? Therefore, in my dissertation, I try to address these two questions using an eye-tracking device. And this high-tech device can actually capture shoppers' visual attention, as you can see from this picture, during the complete shopping trip at a millisecond level. With such accurate data, I use statistical models and estimate, and I found out two main findings. First, shoppers actually have 21 higher chance to look at product display on the right than their left. Second, actually there is a sweet spot that attracts shoppers' attention most, which is around 15 inches below their eye level, which is around arm height from the ground. Before I end, a quick reminder for any grocery shoppers who are interested in saving some of your money. Do not always look at on your right. Do not always look at on your arm height. And check out your shopping list more often because, be careful, someone may lure your attention away. Thank you.
Everyone, meet Sheldon. Isn't he a cutie? Sheldon is a happy-go-lucky baby who at first seems to develop like other babies his age. But if you look closely, you'll observe that his right eye is turned towards his nose. This condition, where the two eyes are pointing in two different directions, is called strabismus. Approximately 1 child in every classroom suffers from this condition. Now, besides the obvious cosmetic effect, children, on growing up, will have difficulty in reading, performing complex math, and even playing catch with his friends. All in all, if left untreated, strabismus will hamper not just his development, but also his education. Now, in order to determine when to wait and when to treat babies like Sheldon, we need to know the exact age at which strabismus develops. In the race to achieve good vision, babies must meet certain visual milestones, and one of the important ones is depth perception. Depth perception allows babies to judge where things are when they start crawling. For example, if their favorite toy is close by or very far away. But strabismus interrupts the development of depth perception, and treatment in the form of glasses or even surgery is required to help these babies get back on track and achieve a 3D view of the world. My research aim is to understand the timeline for the development of strabismus. In an animal model, I simulated the strabismic eye condition since birth by using specialized glasses that contain prisms. Now, some of you must have noticed that when we look at objects very close by, they appear double. The specialized glasses work in the same way, where the two eyes see double images. And this disruption ultimately leads to strabismus. By using photographic techniques, I determined the exact age at which strabismus develops. My results show that initially, during the first few months of age, the two eyes switch between being aligned and not aligned. But at a period of 8 months of age, the two eyes are locked in this condition. Now, what this means is that in order to avoid the consequences of strabismus, treatment needs to start as early as 8 months of age. By targeting treatment during this critical period, we can ensure that all children are winners by meeting not just their depth perception milestone, but other visual milestones as well. In today's competitive environment, a disadvantage can have a significant impact on our future. With my research on the development of strabismus, we can help babies like Sheldon put their best foot forward. Thank you.
Have you ever driven south of San Antonio before? I can tell you from firsthand experience that that area is really sparsely populated. Yet if you take a look at a nighttime photograph of the area, you'll see that there's a bright band of lights that stretch between the metropolitan areas of Corpus Christi and San Antonio. What on earth are these bright lights? These are not those tiny little towns that exude that famous southern hospitality. No, these bright lights are natural gas flaring. You see, in Texas, we dig up so much natural gas that we have more natural gas than storage capacity. As a result, companies are forced to flare or burn their natural gas directly into the atmosphere, which causes these bright lights at night. Oh, and by the way, when you burn natural gas directly into the atmosphere, you create a nasty little molecule called carbon dioxide, which is directly linked to global warming. Yikes. Well, what if you could take all this excess natural gas and turn it into something else, something more useful, or upgrade it? My research is focused on the upgrade of methane, which is the biggest component of natural gas and has a chemical formula of CH4. In particular, I study the field of catalysis, which is the study of turning chemical A into chemical B using some material, usually a metal. Now, the catalysis of upgrading methane is extremely difficult, so difficult that it is considered to be the holy grail of catalysis. Researchers have been working on this problem for 40+ years with limited results. And perhaps you can see an example why on the left side of my screen. You see, if you take methane gas and you flow it over a normal metal, such as gold, you'll get methane gas coming out at the end. Nothing happens. Gold is useless. But if you take methane gas and you flow it over a highly reactive metal, such as palladium, that palladium will strip all 4 of those hydrogens from methane, resulting in something called coke, which reacts with oxygen to form that carbon dioxide. So palladium's useless as well. Well, I've found that if you take one palladium atom, just one, and you put it in gold, you can unlock the key to methane. See, that combination of just one palladium atom in gold allows you to do some real special chemistry. And now you can convert methane into chemicals such as ethylene, which is used in the plastics in your water bottle, for example, or even methanol, which is used as fuel in other countries around the world and in plastics as well. So remember, in the future, whether it's near or distant, as you're sitting on the couch sipping that Fiji water from your water bottle, as you're watching the Golden Globes, maybe you'll remember that that water bottle came from natural gas, all because someone found the special combination of metals to unlock the holy grail of catalysis. Thank you.
And I'm hungry. What am I hungry for? I'm hungry for knowledge, I'm hungry for experiences, and so much more. What am I hungry for? A burger. I don't know about anyone here, but the last thing I want to do is that I go to a restaurant, spend at least 1 or 2 hours at my dinner after working all day. I just want to go home, have my dinner ready, and spend time with my family. I know that all my fellow colleagues can emphasize with me, but don't worry, there is a solution. Uber Eats, Grubhub, DoorDash deliver food to you, no questions asked. They are not the only ones. They are too much to name. My goal for my study is to find out what drives people to use online food delivery systems.
I know my reason. After working so hard at my PhD, I get lazy when I come back home. But I really want you to understand what drives people to use online food delivery systems. The only way for us to understand what drives people to use online food delivery systems is through surveys, technical implementation, and statistical modeling. Our primary experiment consists of surveys that ask participants focused questions that regard their technology acceptance of online ordering. What I mean by that, social influences, convenience orientation, and price-saving orientation. As an example of question from my survey is, I prefer to spend as little time as possible to place an order. Strongly agree and strongly disagree. The result of my study will help better understand the use of online food delivery system by general public. Also, with this information, we are able to develop new experiment toward online food delivery systems. Secondly, from a managerial perspective, the result of our study will help restaurants manage their resources, focus more on food quality and cost by not requiring any delivery staff. And also, they're able to accommodate more consumers while they're providing online option. Our current focus within the USA right now, but we're hope to expand on the global scale in the future. Thank you for listening to me today. Again, my name is Nefike Gunden, and I'm still hungry.
Everyone's heard of the opioid epidemic. There's been a recent rise in the number of opioid-involved overdoses and deaths. But what you probably didn't know is that over 70% of people that have problems with opioids started with a prescription from their doctor for pain. Now, opioids don't work as well as you think they do. While they may take away pain in the moment, they're actually associated with greater pain over time. So that means that people need to use more and more opioids to manage the very same pain. So naturally, people have been looking for other strategies to manage their pain. And given the recent legalization of marijuana across many states in the United States, people have been turning to marijuana to manage their pain, and it works. But what we don't know is what happens when people try to manage their pain with both opioids and marijuana. So that's why we conducted a study with 450 people with chronic pain. All of them used prescription opioids, and some of them also used marijuana. And we asked them a number of questions about their mental health, physical health, and substance use history. Now, let me tell you about betta fish. So let's say you go to the store, you buy a betta fish, you buy a nice tank, you bring it to the office, it's the office favorite, you name it Dorothy. You buy a second betta fish, you put it in the tank, and it's not Kansas anymore. Things get out of control really fast, and they fight. Well, that's exactly what we found in our study. For those people using opioids and marijuana compared to those using opioids alone, they reported higher levels of anxiety, depression, and substance use problems. But what they didn't find is any difference on their reported levels of pain. That means that the very thing people were trying to use that additional medication, marijuana, for, didn't help with their pain. So, we know that opioids and marijuana individually work to manage pain, but combining them doesn't seem to have any added benefit. Why might this be the case? Well, it's possible they work on the same mechanisms in the brain, and therefore there is no additive benefit. But at this point, we still don't know. What we do know is that pain is an essential part of the human experience. While we may not be able to eliminate it, we can do things to better manage it. Thank you.
My research is about developing a test which would help in testing the voice of patients with voice disorders. Now, what are voice disorders? Imagine if you had a voice like this. It would be really, really hard to talk to your family, to your friends, to your parents. We all know about the famous singer Adele. She had some similar problems with her voice in the past, and that is called a voice disorder. Now, when patients with voice disorder go to a speech-language pathologist, they perform a number of tests to find out what is wrong with the voice. And the results of these tests are very hard to understand, just like the blood test reports. Let me give you an example. What if I tell you that the jitter of your voice is 3.17%? Does that make any sense to you? Probably not. But what if I tell you that your voice is perceived as severely harsh by the listeners around you? That would make much more sense. So this process of testing someone's voice on the basis of perception is called perceptual analysis. And we have a test in English language for perceptual analysis. It has a visual scale which helps the clinicians and the patients to know how bad the disorder is. In this test, the patient is made to read a couple of sentences which are constructed in such a way that each sentence has a group of sounds. Let's take an example. One sentence is, "My mama makes lemon muffins." Now, as you would all notice, that this sentence has a lot of M's and N's, just to find out how your nose is helping in producing the voice. Let's take another example. There's a sentence, "Peter will keep at the peak." This sentence has a lot of P's, just to find out how your lips are helping in producing the voice. Now, this test in English language is widely accepted by the speech-language pathologists to find out the perception of voice of English speakers like Adele. But what do we do for the speakers who do not speak English and speak Hindi? How do we assess their voice? Do you know there are more than 500 million people on this planet who speak Hindi language? But unfortunately, we do not have such a test in Hindi. My research is about developing one such test in Hindi language so that the speech-language pathologists can assess the voice of patients who can speak Hindi. I think this is going to be a significant clinical tool for speech-language pathologists all over the world in case they come across a Hindi speaker with voice disorder. Thank you.
I'm sure many of you are familiar with the expression, you can't see the forest for the trees, which means that you can get so caught up on one specific detail that you miss seeing the whole picture. Now, as a hopeful clinical psychologist and researcher in addiction, I try to avoid falling prey to this mindset, but it can be difficult because, as we know, addictions can be all-consuming, and it's often the primary reason for someone coming to treatment. It can be difficult to see anything else outside of the addiction. But there's one substance in particular that I really wanted to focus my research on because it's been dominating conversations with debates about legalization. This substance, of course, is cannabis. Now, cannabis use rates are rising in the United States, but more troubling is that problematic cannabis use rates are rising in the United States among adults. Problematic cannabis use can be classified as heavy, frequent use that often results in multiple problems such as job loss, financial difficulties, and social isolation. But what we're not seeing an increase in is our ability to actually treat these individuals. So I wanted to focus my attention here to see if there was something that we were missing. So what I found is that cannabis users are actually quite a diverse set of substance users. They range in their frequency and patterns of use. I found that heavy problematic users are more likely to report using cannabis as a coping mechanism or as a way to improve their mood. They're also more likely to report using cannabis, or they're more likely to report excessive fear or avoidance of experiencing any type of negative physical or emotional sensations. However, across my sample, I found that all individuals reported similar levels of positive and negative emotional experiences. So it's not necessarily the case that these individuals are using cannabis as a way to reduce their anxiety or their depression, but they're actually so fearful of these sensations that they're using cannabis as a precaution, as a way to avoid feeling any type of distress. This information has very important treatment implications for these individuals, and it could change the trajectory of their treatment. So as you can see, cannabis users are quite diverse. They range in their problems and severity of use. They have different needs and reasons for using. We can't take a one-size-fits-all treatment approach with these individuals. We have to treat the person as a whole, not just the addiction. We have to see the entire forest beyond just the trees. Thank you.
Galveston Bay is located just south of Houston, Texas, the oil and gas capital of the United States. It's estimated that up to 50% of all U.S. oil refineries and chemical manufacturers are located here. It's from these industrial sites that lead enters into Galveston Bay. Lead is a pollutant of concern because it's toxic, even at low concentrations. Lead has been shown to cause weakened kidney function, nerve tissue damage, reproductive system impairment, and even death in both humans and animals. Currently, local regulators are working to clean up lead pollution in the bay, and that's where my research using lead isotopes comes into the picture. I know the word isotope can sound a little intimidating, daunting, even scary, but we can think about it like this. Ice cream comes in different flavors, like chocolate, strawberry, or vanilla. Well, lead comes in its own flavors, or isotopes. It's been shown that when lead is emitted from a source, it gets stamped with its own unique flavor. And as that lead moves throughout the natural world, it retains that unique flavor that it received from its source. For example, if we know that Houston Oil Refinery A emits a chocolate-flavored lead, then we go out into Galveston Bay, sample some waters and sediments, analyze their lead, and find that same unique chocolate flavor. We can then trace the lead that we found in the bay back to that Oil Refinery A source. It's this unique tracing technique that makes lead isotopes so valuable because it allows us to identify lead sources and understand lead transport. This information is crucial in assisting regulators with cutting off lead pollution at its source, as well as cleaning up lead pollution as it occurs throughout the bay. I think the photo on this slide does a good job of illustrating our connections as humans with Galveston Bay, whether it be through industry, as we see looming in the background, or recreation, like fishing. We as humans are leaving our mark. The goal of my project is to use lead isotopes to reduce the amount of lead pollution in Galveston Bay and help make more sustainable use of this beautiful natural resource for generations to come. Thank you.
What do you want to be when you grow up? When I was a child, I struggled mightily with this question. I wanted to be an astronaut and soar among the stars. I wanted to be president. I wanted to be a doctor. But I find it amusing that right now my research here at the University of Houston is studying cells and what they want to be when they grow up. So I work with pluripotent stem cells. They are like the ball on the top of this mountain behind me. As they roll down, or as they choose their fate, they become all the cells in the body. But each fate is delineated by which path it takes. My research focuses on modulating the genetic pathways that the cells take to encourage them to turn into heart cells, specifically beating heart cells. Now, humor me for a second. Take your 2 fingers and feel for your pulse. Mine's not too fast. Did you know your heart is the first organ to form in your body before you're born? And after you're born, about 90% of the muscle cells in your heart are already there and will be there with you for the rest of your life. Now, I find that utterly fascinating. But there is a problem. If you damage a heart cell, that means you don't get them back. My research seeks to fix that problem. You see, every 40 seconds in the United States, one person suffers a heart attack. During a heart attack, muscle cells in your heart die and never come back. My research seeks to take the patient's own cells and help their cells turn into the cardiac muscle cells that they have lost, so that we can either build a Band-Aid and patch it into their heart, or we can create some other patch outside of their body and later restore their heart to function. So I ask you again, what do you want to be when you grow up? That is the heart of the matter.
Agricultural crops face numerous challenges, including pest insects. These are insects that can come into a farmer's field and they'll eat anything in sight. This decimates profits and undermines food security. If we want to develop a more sustainable agricultural system, we need to learn how to help plants help themselves. The good news is that there's already a biological basis for this. Plants produce chemical compounds to protect themselves from insects. So what happens is that an insect will come along and start chewing on a leaf, and this cues the plant to start producing pretty nasty chemical compounds in their leaves. This could make the plant taste terrible, or it could physically harm the insect, but the result is the same because either way, that insect walks away from that plant. That's fantastic, except for the fact that not all plants can produce that same type of chemical protection for themselves. Some plants are really strong. They can produce lots of chemical compounds and protect themselves, whereas other plants are weaker. They seem to struggle to protect themselves. This variation or variability in a plant's capacity to protect itself against insects has baffled biologists for decades. My hypothesis is that this variation is explained by what type of below-ground partnership you have. So plants, through their roots, can associate with tons of different microbes. When we say microbes, we mean bacteria and fungi. And this is a very close relationship. So close that I've actually included a picture on the right-hand side of a root underneath a microscope that has fungi living inside of it. And we suspect that this type of close relationship with bacteria and fungi can alter a plant's capacity to protect itself. The problem is we don't know which microbes can suppress a plant's immune system and which promote it. That's where I come in. I grow plants with soil where I control which bacteria and fungi are in the soil, and then I test the plants against insects, and I see what their immune response is like. My hope is that we can identify the bacteria and fungi that protect the plants the most so that we can work with farmers to develop a more disease and pest-resilient agricultural system. The more resilient our agricultural system is against pest insects, the more capable we are of feeding 7 billion people. Thank you.
How many of you know someone with some type of kidney disease? How many of you know someone that is going through dialysis and waiting for a kidney transplant? Now imagine going through the transplant surgery, getting a new kidney, but the new kidney fails as well. You'd be surprised how often that happens. 40% of the patients that go through the transplant surgery end up getting their chronic kidney disease back. 40%. We call it the recurrence of their kidney disease. This is Lauren, a 10-year-old girl that went to the doctor with a simple sore throat. That on the right is Lauren 1 year later. Both her kidneys have failed. The kidneys are leaking protein into the urine, and as a result, you can see the soft tissue in her face and the rest of her body have swollen. We call that edema. She's doing dialysis several times a week and waiting for a new kidney. The story doesn't end there. Lauren ended up getting a new kidney. She was doing better. She was in remission. However, a few weeks after the surgery, she was back in the hospital. The new kidney failed too. The physicians were confused at first. This was not the case of organ rejection after transplant surgery. This was something else. we now know that there are factors in her blood that cause the new kidney as well as her own kidneys to fail. So what we do in the lab is we study the effect of these factors on the kidney structure and kidney function. Each of our kidneys have 1 million tiny dialysis machines we call nephron. Within these nephrons, we have cells that filter your blood and create the urine. On the surface of these cells, we have a very important protein. It's called trypsin-6 channel. We have shown that the factors we talked about in the blood of Lauren and patients like her actually increases this channel protein within these cells. As a result, these cells die, and you start to show the sign of kidney failure. We're hoping by studying the properties of this channel, we can use it as a drug target, so we can find a way to block it. So patients like Lauren don't have to wait for a new kidney. Just as soon as we detect these factors in their blood, we can administer the drug to block the channel, and we can save their own kidneys. Thank you very much.
Can you imagine what it feels like to have an abnormal growth inside your body? To realize that your body is suffering from an illness that doesn't respond to any medicine, that you've been diagnosed with cancer. Cancer is the second leading cause of death globally and is responsible for about 9.6 million deaths in 2018. The survival of cancer cells depend critically on mitochondrial function and oxygen supply to the cells in our body. The mitochondrion is a unique and complex structured organelle that exists within our cells and uses oxygen to convert chemical energy from food to ATP, a molecule that supplies energy for cellular functions. We have trillions and trillions of mitochondria, making up about 10% of our body weight, and transferring cellular energy through electrons along these protein complexes in the membranes. As a physicist, I study the mitochondria as an electronic circuit, where its biological functions can be defined by movement of electrons. And these electrons choose pathways that use the least amount of energy to jump from one atom to another. In my theoretical research work, I found that these electron pathways, just as shown here, going through one of the protein complexes, can change its path in cancer cells that have mutated mitochondria.
And this changes how energy is fueled across atoms and causes an imbalance in the metabolism of the cell. The experimental part of my thesis work uses an electric field to penetrate the mitochondrial membrane and measure changes in impedance of normal and mutated mitochondria, focusing on how synthesis of this molecule ATP is affected by the transport of electrons. So the significance of my studies to understand all these underlying molecular mechanisms that affect the growth of cancer cells is to be able to identify what changes in the mitochondrial characteristics so we can develop early detection methods of aggressive high-risk cancers and recognize how it is changing the mechanism of energy production in our bodies. Because after all, the mitochondrion is the powerhouse of the cell and is an integral part to our survival. Thank you.
Amputees are capable of so many remarkable things. One of the things that's helped to make this possible is the development of modern prosthetic technology. So many of these individuals go on to show us how capable they are. These devices have helped individuals to do numerous things. The gentleman in this photo is using a microprocessor knee, or a knee with a computer chip in it, to do a challenging task. That is, to walk up a flight of stairs. As advanced as this device may be, it lacks one fundamental property. As I stand here in front of you and I walk around this room, I don't think to myself, move the left leg, move the right leg, bend the left knee, bend the right knee. Instead, my brain and my muscles work in synchrony to allow me to perform this task. These devices, as they currently are, lack the ability to interpret a user's intent or desire to make an action. This is the challenge that I am working to address for amputees. But to do this, we have to solve two problems. The first is to understand how limb loss affects the brain. So we're using non-invasive functional magnetic resonance imaging to scan the brain of amputees, specifically above-the-knee amputees, as they attempt to move their now missing limb. The second problem is to bridge this communication gap between the device and the brain and the representation of the limb after amputation. So we're using non-invasive sensors to measure electrical signals of the muscle and the brain while they try to make these movements, and trying to interpret what information is relevant to their desire to perform the action, and then translate this information into a language that these devices can use to facilitate control of the system. My hope is that with these devices amputees will be able to demonstrate control of the systems using only their thoughts, will be able to better understand limb loss and how it affects the brain. We can improve the mobility and quality of life for amputees. And finally, amputees will be able to demonstrate to us one more remarkable thing that they're capable of. Thank you.
Did you know that Ryan Gosling and I have something in common? Both of us have a disorder called strabismus, which means that our eyes don't always line up straight all the time. And you've probably seen people who have this, because more than 700,000 cases are reported each year in the US alone. And if it's left uncorrected, it can lead to severe vision loss. But the best way to correct it, using glasses and surgeries, aren't always successful. When you have two eyes that are facing the same direction, they see the same image. So the brain is easily able to put them together to see one common view of the world around us. But if your eyes are facing different directions, they're sending back different images, like that of a cat and dog, which the brain simply cannot put together. It's like trying to fit mismatched pieces of a puzzle. It just won't work. So, to compensate, the brain just chooses an eye to ignore. And it does it through visual command centers in the brain. But which eye it chooses can be quite variable. So that's the goal of my research. It's to understand these command centers and how they take information from our different senses, like what we see and what we hear, and use this information to pick one eye over the other to locate objects. To do this in my lab, we use neurosensory technology to record brain signals from strabismic animals. And what we've learned so far is that there's a competition going on between the two eyes. Think of it as like having two teams, team left eye and team right eye. From my research, what we found is that when the brain senses that there's an object of interest, like a cute puppy barking, on the left side, the cells in team left eye get super excited, and they send a message for the left eye to look at the puppy and for the right to ignore what it sees. And this competition happens over and over again to pick either eye. But if the brain chooses to ignore one eye more than the other constantly, it can lead to losing vision in that eye permanently. So although it may look nice to look like Ryan Gosling, the consequence of having strabismus can be quite detrimental. So by using what we've learned so far about how the processes in the brains of strabismics actually work, we have hope to find better and effective ways in correcting strabismus for future generations. Thank you.
On behalf of the graduate school and U of H, thank you all for coming. Thank you for participating, everybody who tried out. Thank you to the finalists. If you please, note your favorite. Go online and vote for audience favorite for viewer's choice. And at 5 o'clock in the Houston room upstairs, we'll be having a reception and the awards ceremony. There'll be refreshments. Please join us. Thank you very much.